Vanakkam. Now we are going to deal with problem number 2.6 from Digital Design by Moris Mano's 5th edition. The question is to draw logic diagrams of the circuits that implement the original and simplified expressions in problem 2.3. So we need to refer problem 2.3. There the expressions are given and for which we have already found the simplified versions also. Okay. So now we'll draw the logic diagram for each and every Boolean expressions and its simplified form also. So the first one is A, that is ABC plus A dash B plus ABC dash. So when you refer this Boolean expression, here we have three terms and this is the first term and this one is the second term and this is the third term. So in the first term, if you look at it, here it is ABC. So ABC means it is actually connected using this dot. Okay. So this is AND operator is used here. And there actually we have three input AND gate is needed. Okay. Then when you refer this A dash B, here what are the gates we require? This in order to get this A dash, we have to have one inverter and then this A dash and B are connected using this dot product. That's why we need two input AND gates. Okay. And the last term is ABC dash. Okay. So ABC dash in the sense, first we have to get the C dash. For that we need one NOT gate or an inverter. And then this ABC dash are connected using this dot product, isn't it? So that we need three input AND gates. And then this three are connected using this plus sign, right? So that we need three input OR gates or operator. So how many gates we need here? This is one 3 input AND gate, then one NOT gate, another 2 input AND gate and another NOT gate, then 3 input AND gate. So this is fifth gate and here we have the sixth gate. So we need 6 gates in order to implement this function using the logic diagram. Now we'll implement the logic diagram. Here we have 3 literals A, B, C. So that we need 3 input lines. So one, this is for B and this is for C. A, B, C, 3 input lines we have. We name them as A, B and C. Then the first term is to be implemented. So A, B, C. So we take the connection from here. This is A line. Then connection taken out of this B. Then connection taken out of this C. So these three are given as input to 3 input AND gate, isn't it? So we'll use this 3 input AND gate and the output we'll take it from here and we name it as A, B, C. So we got the output as A, B, C. Then the second term is A dash B. So we have to take the connection out of this A. Then it should be given to one NOT gate inverter so that we get the output of this NOT gate as A dash. Then we have to take the connection from this B and these two inputs are applied to 2 input AND gates. Okay, then we get the output of AND gate as A dash B. Okay, then we go for third term. Third term is A, B, C dash, isn't it? So we take the connection from this A and then take the connection from this B and we take the connection from this C, but we need C dash. So we take this, the C line is given to one inverter and the output of this inverter is C dash, isn't it? So these three are now given to 3 input AND gate. So this output is now ABC dash, ABC dash. Then we have to combine these three outputs using 3 input OR gate, isn't it? So this is given to 3 input OR gate. So at the output we'll get the function. Okay. So the function is f is equal to ABC plus A dash B plus ABC dash. Now we go for this simplified. Say f simplified is B. So just to take the connection out of this. So we'll get this f simplified. Okay. Because it is B. That's it. Now we move on to the second one. So this is our second Boolean expression. So f is equal to x dash y z plus x z. For this we have to draw the logic diagram. Okay. So here if you look at this, here we have two terms. So this is our first term and this is the second term. So what is available in the first term? In the first term we have this x dash y z. So x dash, in the sense here we need one or one NOT gate inverter. Okay. Then this x dash dot y dot z, that means it is AND operator. So for this we need 3 input AND gate. Okay. Then the second term, that consists of this x z, that means dot operator. So we need 2 input AND gate. And the first term and the second term are combined using this, connected using this OR. So we need 2 input OR gate. So how many gates we need? This is one NOT gate, 3 input AND gate, 2 input AND gate and 2 input OR gate. So we need 4 gates. Okay. Now we'll proceed. 3 literals are there, so we need to draw 3 input lines. So let's name them as x, y, z. So take the connection out of this x, then give it to one NOT gate, and the output is x dash here. Then we take the connection out of this y, then we take the connection from this z line. So these 3 lines are now combined using this 3 input AND gate, isn't it? So they are given to 3 input AND gates. So the output of this AND gate is x dash y z. Similarly we go for the second term. So the second term is x line is taken and then z is taken, and they are connected using 2 input AND gate, isn't it? So it is 2 input AND gate. So the output at this line is x z. Then these two terms are connected using 2 input OR gate. So we get the required function f. So f is equal to x dash y z plus x z. So we have to draw the logic diagram for f simplified also. So when you consider this f simplified here, this is z is our first term. So this z is first term and this x plus z. So when you consider this f simplified, z is one term and this x plus y is our second term. So in the first term only z alone is there, but in the second term x plus y is there, isn't it? So x plus y means we need to have a 2 input OR gate. Then this z is ANDed with this x plus y. For that we need 2 input AND gate. So totally we have two gates. We need two gates. This is gate number 1 and this is gate number 2. So we require two gates. Okay, now we will proceed to draw. So first we will take the line from this Z, then we take the line out of this X, then we take the connection from this Y, so now we are going to draw logic diagram for this Boolean expression, both in the original form and its simplified form. So here f is equal to x plus y the whole dash ANDed with x dash plus y dash. So here this is our first term and this is the second term. Here we have only two literals, so we have to draw only two input lines. So that is x and y. So we name the input lines as xy. We have to take the connection out of this x, then we take the connection out of this y, then both are combined using two input OR gates. So we have to make it here two input OR gates. Then the output of this OR gate will be connected to an inverter. The output of this one is x plus y the whole dash. Because this is x, this is y. At this side you get x plus y and here you get x plus y the whole dash. So the first term is over. Now we draw the logic circuit for this second term. So it is x dash first. So take the connection out of this x and give it to one inverter. Then take the connection from this y line and again it is to be given to another inverter or a NOT gate and the output is taken out of this. So here it is x dash and here it is y dash. These two are actually combined using plus operator, that is on OR gate is required, isn't it? So we need a two input OR gate for this. So the output line is taken and it is named as x dash plus y dash. Okay, now these two lines are connected. So these two lines are given to two input AND gates. So that we'll get the final output for this. That is f is equal to so now we got the function f is equal to x plus y the whole dash ANDed with x dash plus y dash. Now we'll proceed with this f simplified. Now we'll proceed with the f simplified. So in order to draw the logic diagram for this f simplified, first we have to get x dash. So we have to take the connection from this x and then we apply it to a inverter or a NOT gate. And this output of this NOT gate will be giving us x dash. And we take the connection from this y and it is given to another NOT gate and the output is now y dash. These two are now applied to one two input AND gate. So the output of two input AND gate is now F simplified. So the output of two input AND gate is now F simplified, that is equal to X dash Y dash. Okay, so we have completed the logic diagram for the C problem. Now we'll move on to this. The D problem. So in this actually we have this F function is xy plus x into wz plus wz dash. Okay, so here we have how many terms? Only two terms. This is the first term, and this x multiplied or ANDed with wz plus wz dash is our second term. Okay, so first term, when we consider this first term xy, it is ANDed, right? In between this x and y we have this dot product, so it is a two input AND gate that can provide this function. Okay, then when you look into the second term, there it is w into x into. So when we see the second term, in that we have x ANDed with wz plus wz dash, isn't it? So here z dash is there, so in order to get z dash we need a inverter or a NOT gate, and this can be obtained, that is wz dash, that is in between this dot is there, so one number of two input AND gate is required. And if you look at this here, this wz, for this also we need a two input AND gate, and in between this we have this plus. Okay, these two are ORed, so for that purpose we need a two input OR gate, and then this whole thing is actually dotted with this x, isn't it? So x dot of this function, so for that we need two input AND gate again, right? So how many gates we need? This one. Here it is one gate, then for this purpose second gate, 3 4 5 6 gates we require to implement this function. Okay, so let's start now to draw the logic diagram. Okay, so now we'll start drawing the logic diagram for this Boolean expression f. So here we have three literals x, w, z. W, x, z. So we draw three lines, three input lines. And we name them as W. We need four input lines. So we need four input lines as we have four different literals x, y, w, z, right? So we draw four input lines. So we name them as W, X, Y, Z. W, X, Y, Z. Okay. So for the first term, we take the connection from this X and then take the connection from this Y, and they are combined using this two input AND gate, and the output is giving us The output is xy. Then we go for the second term. In the second term, first we need to find out. So in the first term, we can take the connection from this x first. We can take the connection from this x and then take the connection from this w and z. So this is w and z. This w and z are combined using this two input AND gate, so that at the output of this AND gate we get wz. Then we take another connection from this w and z. But this z bar is required here, or z dash is required. So we need to have an inverter, and the output of inverter will give us z dash. So these two are actually given to two input AND gate. So at this output we get w z dash. Then these two must be combined using OR gate because we have a plus sign there. So we give it to a two input OR gate, and then this along with the x, okay, this is x line already we have taken, they must be given to two input AND gate. So here we get the second term completed. So this is, you know, that it is x ANDed with wz plus wz dash, isn't it? Now we have to combine this first term, that is xy, and the second term using OR gate, isn't it? That is two input OR gate. So at the output of this we get f, okay. So we get the f at the output. That's it. Now we go for implementing this f simplified. So f simplified, in this we have first term as x, that is ANDed with the second term y plus w. So first we'll take this x connection. First we'll take the x connection and then y plus w. So we take the connection from this w. They are y plus w, right? So this y and w must be given to a two input OR gate. So at the output of this we get y plus w, and this along with the x ANDed, right? So we get it. They must be applied to two input AND gate. At the output will get the function simplified. Okay. So we get this. So that's all for this logic diagram. So now we are going to draw the logic diagram for the CE problem, that is f is equal to bc dash plus a dash d ANDed with ab dash plus cd dash. So we'll start away directly. So here we have four literals, so we have to draw four lines. So it is A, this is for B, and then we draw another line for this C, another line for this D. So we have drawn the input lines A, B, C, and then D. Now we start with the first term. The first term is BC dash plus A dash D. Okay, so we are going to get this. So for that we have to take the connection from this B first, then C dash. So take the connection from here and give it to one inverter. So at the output we get it as C dash. These two must be combined using one AND gate, two input AND gate. So at the output we get BC dash, isn't it? Next we do with this A dash D. So we take the connection from this A dash, means take the connection from this A, give it to one inverter, and the output of this one gives us A dash. And we take the connection from this D. These two are now given to one two input AND gate. So the output of this AND gate we get A dash D. Okay, so these two are to be combined using, so the output of these two AND gate must be combined using two input OR gate. Okay, so this output gives us the first term. Okay, that is BC dash plus A dash D. Then we go for the second term. So what is second term? This AB dash plus CD dash. So we take the connections for this. We have to take the connection from this A. Then we need to take the connection from this B. It must be given to one inverter so that we get the B dash. Then the output is B dash, right? These two, that is AB dash, are combined using two input AND gate. So give it to a two input AND gate. The output of this AND gate gives you AB dash. Then we take the connection from C, and then from this D dash, that means D given to your inverter. So given to your inverter, and the output is D dash. These two are now given to one AND gate, two input AND gate, so that we get this as CD dash. These two must be now combined with the help of one OR gate again, two input OR gate, right? So okay, so the output is now our second term. The first term and the second term are now combined using two input so they are combined using two input AND gate. So this output is the function, isn't it? So this is the function we have done for the original logic expression. So we got the logic diagram for this original Boolean expression. Now we go for the simplified, and the simplified one is 0, right? So we cannot take the connection from this input line. Simply you can get the line, output line, without any connection, so that you get the answer as f simplified is equal to 0. That's it. So now we are going to draw the logic diagram for this f problem. That is, the function is given as a dash plus c dash ANDed with a plus b dash plus c dash. This is the original, and the simplified is a dash b dash plus c dash. Okay, so here how many literals we have? 3 literals. So we need to draw 3 input lines. So this is for A, then for B, then another line for this C, and we name them as A, B, C literals. Then for implementing this, this is the first term and this is the second term. First term is A dash plus C dash. So first we'll go with that. So A dash means take the connection from this A and then give it to a inverter. At the output of the inverter we get this A dash, and then take the connection from the C, give it to another inverter. So at the output of this inverter we get C dash. These two must be combined using 2 input OR gate, isn't it? Given to 2 input OR gate. So the output of OR gate will give us the first term. What it is? It is A dash plus C dash. Then we'll implement the second term. Second term is A. Take the connection from here. A. Then we have this B dash. So take the connection from here. Give it to an inverter. Inverter gives us B dash. Okay. Then we take the connection from the C dash. So we have to get C dash. That means take the connection from C and then give it to an inverter. So we get C dash here. All these 3 must be combined here, isn't it? In order to get A plus B dash. All these 3 must be combined to get A plus B dash plus C dash. So we need a 3 input OR gate. So at the output of this we get the second term. What it is? It is A plus B dash plus C dash. It is A, here we have B, C dash. So now we have to combine this first term as well as the second term. Using 2 input AND gates. And the output of this AND gate will give us the required function, isn't it? So now we have implemented the logic diagram for the original. Now we go for the simplified. So here we have again 2 terms. This is first term A dash B dash, second term is C dash alone. Both are combined using plus. So take the connection from here. This is A dash we need, right? A dash. So I have to give this to your inverter. The output is this one, A dash. Then take the connection from this B. It must be given to your inverter again to get the B dash. Okay. These two must be combined using two input AND gates. For this. At the output we get A dash B dash. Then we have to take the connection from C in order to get the C dash. Okay, so take the connection out of this, give it to an inverter. Okay, C dash. So these two must be first term and the second term must be combined using OR gate, show input OR gate. The output will give us the simplified one, right? So here it is C dash. So the output, so this output gives us the simplified A dash B dash plus C dash. So this is the logic diagram for the simplified one. Thank you.